Namaste, good evening. So today we will discuss the numericals related with solutions chapter. And yesterday we have discussed the formulas related with the concentration expression terms, but today we will discuss some NCERT questions related with the solutions chapter from the expression of concentration of the solution. So let us discuss the first numerical here. Calculate the molality and mole fraction of 2.5 gram of ethanoic acid in 75 gram of benzene. Here you have to apply the formula for molality and mole fraction. How will you apply the formula and how to calculate the values here? So first of all, see, molality is equal to the number of moles of solute divided by the mass of solvent taken in kg. Mass of solvent taken in kg. Okay, mass of solute, which is the solute here in the question, 2.5 gram of ethanoic acid. So ethanoic acid is acting as a solute here, and 75 gram of benzene, it is dissolved in 75 gram of benzene. So benzene is the solvent here. Okay, now moles of solute is calculated by dividing the mass of ethanoic acid, that is 2.5 gram of ethanoic acid, by its molar mass. So what is the molar mass of ethanoic acid? CH3COH. CH3COH. So it will be equal to 24 plus 4 plus 32, which is 60 gram per mole. Okay, now we will get the number of moles. 2.5 gram divided by 60, it will be equal to the number of moles of solute, that is ethanoic acid. And how to get the mass of the solvent in kg? So this is the mass of the solvent, 75 gram. To convert it into kg, we will divide it by 1000. Okay, so this will give the value of molality, which is equal to 0.556 mole per kg. So write down the units with your answer, or write down here mole per kg in terms of mole per kg or small m. Okay, so this is the first part that we have calculated here. The second part is to calculate the value of mole fraction of ethanoic acid. How to calculate the mole fraction value for ethanoic acid? So put down the formula first. What is the formula of calculating mole fraction of ethanoic acid? It is equal to number of moles of ethanoic acid divided by total number of moles present in the solution. So here the total number of moles means the two components present in the solution, that is ethanoic acid and benzene, the number of moles of ethanoic acid and number of moles of benzene. Okay, so here we will first put down the values and then we will calculate the value of mole fraction for acetic acid. To calculate the number of moles of acetic acid, see, 2.5 gram by 60 we have already calculated here. Put down the values, 2.5 by 60 and divide it by again 2.5 by 60. It will be number of moles of acetic acid plus number of moles of benzene. So number of moles of benzene will be equal to 75 gram of benzene, which is the given mass of benzene. Divide it by molar mass of benzene. Molar mass of benzene is equal to, see, 12 into 6, 72 plus 6, which is equal to 78 gram per mole. So it will be 78 gram per mole. Now we will get the mole fraction value for acetic acid, and it is equal to 0.0416. This is the value of mole fraction of acetic acid in the solution. Okay, now we will take the next numerical. This is calculate the mole fraction of ethylene glycol and water in a solution containing 20% of ethylene glycol by mass. So how to calculate the values here? Okay, see here, if the mass percentage of ethylene glycol is already given in the question, then it means that mass by mass of ethylene glycol means 20 gram of C2H6O2 and 80 gram of water is given as the mass of both the components in the solution. There are two components in the solution, ethylene glycol and water. If the mass percentage is given, then it means that 20% of ethylene glycol means 20 gram of ethylene glycol is present in 100 gram of the solution or 80 gram of the solvent. Okay, so this is the mass present for both components in the solution. Now calculate the mole fraction value and apply the formula here. Mole fraction of ethylene glycol. Mole fraction of ethylene glycol is equal to number of moles of ethylene glycol, C2H6O2, divided by total number of moles present in the solution, C2H6O2 plus number of moles of water. Okay, so this is equal to, put the values here, number of moles of C2H6O2. How to calculate C2H6O2 ethylene glycol number of moles? Here divide the given mass of ethylene glycol with its molar mass. Okay, so we need the molar mass of ethylene glycol C2H6O2 as well as the molar mass of water here to calculate the number of moles for both the components. Okay, now the molar mass of C2H6O2 will be equal to 12 plus 12 plus 6 plus 32. It will be equal to 62 gram, and molar mass of water is 18 gram. So here the number of moles of ethylene glycol will be given mass divided by its molar mass, and again 20 by 62 plus number of moles of water 80 divided by 18, and after calculation the value is coming out to be 0.068 number of this is mole fraction value. Okay, because we are dividing the moles with moles, so it is a dimensionless quantity. A mole fraction is a dimensionless quantity, and it is equal to C2H6O2. So this is the second numerical that we have done here. Now let us calculate the third numerical. How to calculate it? Calculate the percentage, mass percentage of benzene and CCl4 if 22 gram of C6H6 is dissolved in 122 gram of CCl4. How to calculate the mass percentage of benzene and CCl4? Okay, so how to calculate it? Now, because you have been given the mass of benzene, it is equal to 22 gram, and mass of CCl4 is equal to 122 gram. Now to calculate the mass percentage of CCl4 as well as for benzene, we have to calculate the mass percentage for both of the components. What you have to do? You have to divide 22 gram by total mass of the both components present in the solution. This will be equal to the mass percentage of benzene. Okay, mass percentage of benzene is equal to 22 gram divided by total mass present in the solution, and the another component, mass percentage of another component, that is CCl4, is equal to 122 gram divided by total mass present in the solution, that is 22 plus 122 gram. Okay, so these will be the values of mass percentage. Now let us see what are the values here. For the mass percentage of benzene, it is 15.28%, and for mass percentage of CCl4, it will be equal to 84.72%. Because there are only two components present in the solution, so you can also subtract the another value from unity. Okay, to calculate the value of mass percentage of CCl4, subtract it from unity. Subtract the value of mass percentage of benzene from unity to get the mass percentage of CCl4. So this is how you can calculate the mass percentage of both of the values. Okay, so this is the third numerical. Now calculate the mole fraction of benzene in solution containing 30% by mass in CCl4. How to calculate the mole fraction of benzene in solution containing 30% by mass in CCl4. So here again put the formula how to calculate the mole fraction of benzene. Mole fraction of benzene is equal to number of moles of benzene divided by total number of moles present in the solution, which is number of moles of benzene as well as the number of moles of CCl4. Okay, so you will get the mole fraction of benzene in the solution. To calculate the number of moles of both the components, you need the mass of each component as well as the molar mass. Okay, so let us put the values here, which is equal to mass of benzene. What will be the mass of benzene? Okay, what will be the mass of benzene present in the solution? See, if 30% by mass in CCl4, this means that 30 grams of CCl4 is present. Calculate the mole fraction of benzene in solution containing 30% by mass in CCl4. This means that benzene has 30 gram mass, 30 gram mass, and CCl4 has mass of CCl4 is equal to 70 gram. Now to calculate it in terms of moles, divide it by molar mass. To calculate the molar mass, you need the formula of both the compounds. Okay, so molar mass of benzene is equal to 12 into 6 plus 6, that is 78 gram per mole, and molar mass of CCl4 is equal to the 1 chlorine 35.5 into 4 plus 12, and the mass molar mass of CCl4 is equal to 154 gram per mole. Okay, so this is how you will get the number of moles. Put down the values here and see number of moles of benzene, 30 divided by 78, and then again 30 divided by 78 plus mass of CCl4, 70 divided by 154. Okay, so this will be equal to the mole fraction of benzene. Mole fraction of benzene, 30 by 78 divided by 30 by 78. This means the number of moles of benzene plus number of moles of CCl4. After calculation, you will get the value that is equal to 0.458, and mole fraction of another component CCl4 is equal to 1 minus 0.458, which is equal to 0.4542. Okay, this will be the value of CCl4 mole fraction. So this is how we can calculate the mole fraction of benzene in solution containing 30% by mass in CCl4. This the numerical related with mole fraction. Now the next numerical is calculating the molarity of each of the following solutions. So there are two parts of the solution. In the first part, there is a mass of cobalt nitrate in the hydrated form, and it is present in 4.3 liter of the solution. How to calculate the value here? So in the first part, the number of moles of cobalt nitrate hexahydrate, cobalt nitrate hexahydrate, you have to divide 30 gram of the mass of solute with its molar mass. What is the molar mass of the solute? It is equal to 290.7 gram per mole. 290.7 gram per mole. Okay, and then you have to calculate the value of molarity. How to calculate the value of molarity? You will get the number of moles here. It is equal to 0.1032 number of moles. Now divide the value 0.1032 number of moles with the volume of the solution, which is already given in liters. So you will get the value of molarity here, and it is equal to 0.024 molar solution or mole per liter of the solution. This is how we can calculate the first part of the solution. Second part can be calculated as see here what is given in the question: 30 ml of 0.5 molar H2SO4 diluted to 500 ml. See, if there is a component which is diluted to another volume, and we have to apply the formula of molarity equation to get the molarity of the new solution formed after dilution. So it will be equal to M1 V1 is equal to M2 V2. M1 is molarity of H2SO4, that is 0.5, and V1 is 30 ml of the solution. M2 is the new molarity of the solution, and V2 is volume of the solution, that is 500 ml. How to calculate the value of M2? This will be equal to 0.03. Okay, so it will be equal to 0.03 molar solution. This is how we can calculate question number 5. Now see the next question. Calculate the mass of urea required in making 2.5 kg of 0.25 molar aqueous solution. So here in the question we have to calculate the mass of urea. Mass of urea required in making 2.5 kg of 0.25 molar aqueous solution. Okay, so we have given here 0.25 molar aqueous solution, which means that we have 0.25 moles of urea dissolved in 0.25 moles of urea dissolved in how much per kg of the solvent, that is 1000 kg of the solvent. Sorry, 1 per kg of the solvent, so 1000 gram of the solvent, or 1 kg of the solvent, that is water. So this is what this value means, 0.25 molar aqueous solution, 0.25 moles of urea divided by 1000 gram of water. Now to calculate the value of 0.25 moles of urea, by using this value we can calculate the new value, that is the mass of urea which is dissolved here to make 0.25 molar aqueous solution. Can we calculate it? Yes, of course we can calculate it, that to make 0.25 molar aqueous solution, how much mass of urea you need? 0.25 moles of urea is equal to, it is equal to 0.25 into the molar mass of urea, NH2CO NH2, it is equal to 60 gram per mole. Okay, because the number of moles is equal to mass of solute divided by molar mass of the solute. If we multiply the number of moles with molar mass, we will get the mass of the solute. Okay, we will get the mass of the solute. We will get the mass of the solute here, 0.25 into 60. This means that the value is coming as equal to 0.25 into 60, 15 gram. 15 gram of urea is dissolved here to make 0.25 molar aqueous solution. Okay, in 1 kg of the solvent, that is 1000 gram of the solvent. But we need to calculate the mass of urea in 2.5 kg of the 0.25 molar aqueous solution. So you have to calculate here the value in 2.5 kg of the solution. If the total mass of the solution is 1000 plus 15 gram is equal to 1.015 kg. Okay, 1000 gram is the mass of the solvent, 15 gram is the mass of solute, and it will give the mass of the solution, that is 1.015 kg. So 1.015 kg, 1.015 kg, it contains 15 gram of urea. It contains 15 gram of urea. 2.5 kg will be having 15 divided by 1.015 into 2.5. Okay, and it will be equal to 37 gram of the solute. 37 gram of the solute is dissolved in 2.5 kg of the solvent. Okay, so this will be the value here. So this is the 6th question that we are solving here. Now see the 7th question. Calculate molarity, mole fraction of potassium iodide if the density of 20% mass by mass aqueous potassium iodide is given here. How to calculate the value here? Molarity as well as mole fraction. To calculate molarity, first you need the mass of solute, that is moles of solute. You need moles of solute divided by mass of solvent in kg. So to calculate mass of solute, moles of solute, how will you calculate the moles of solute? You need mass of solute as well as molar mass of solute. Potassium iodide is the solute here, which is 20%. This means 20 gram divided by potassium iodide. Molar mass of potassium iodide is equal to 166. 166, 39 plus 127, 166 gram per mole. 20 by 166 is equal to moles of solute. We will divide it by mass of solvent taken in kg. So, the remaining mass of water will be equal to 80 grams. Divide by 80 and convert into kg by dividing 80 by 1000. Now, it will be 20 by 166 into 1000 by 80, which is equal to molality of the solution 1.5 molal solution, mole per kg solution. Okay, this will be the molality of the solution. To calculate the second part, that is molarity, you need density, because we have to calculate the volume of the solution as well. So moles of solute divided by volume of the solution taken in liters is equal to the molarity of the solution. Moles of solute you have already calculated here, 20 by 166. To calculate the volume of the solution, but you need density, and density, as we know, that density is equal to mass by volume. So volume will be equal to mass by density. Okay, volume will be equal to mass of the solution by density. What is the mass of the solution? Mass of the solution is 100 grams and the density of the solution is 1.202. So 100 by 1.202 is the volume of the solution, which will be again in ml, because we are using the density in gram per ml. So the volume will also be in ml. 100 by 1.202, which is equal to 83.2 ml. But we need the volume in liter, so we will divide 83.2 by 1000. This is how we can calculate the molarity of the solution, and it is equal to 1.44 molar solution. Now calculate the third part, which is mole fraction of potassium iodide. How to calculate the third part, mole fraction of potassium iodide? Mole fraction of potassium iodide is equal to number of moles of potassium iodide divided by total number of moles present in the solution. We have already calculated here the moles of potassium iodide, that is 20 by 166 divided by 20 by 166 plus number of moles of water. Number of moles of water will be equal to mass of the mass of solvent, that is 80 divided by molar mass of solvent, that is 18. Okay, and here we will get the mole fraction value for potassium iodide. Mole fraction value of potassium iodide, it is equal to 0.0263. 0.0263. This will be the mole fraction value for potassium iodide. So today we have solved 7 important numericals from NCERT in text as well as from exercise to calculate the concentration of the solution in various forms like molarity, molality and mole fraction. Hope this will help you. Thank you.